power n, and we are dividing a power m. This is the same as what? When you can see the bases are the same, the base is a, but the powers are different. The first power is n and the second power is m. What do we do is this: when we are dividing numbers of the same base, we subtract the powers. So we just say a power n minus m, and here we shall say provided m is greater than m. This one only applies when the first one is having a bigger power than the second one. So that's what happens to the second law. Then the third law goes. The third law, we are dealing with these ones. If we have a power n, and again there is a power of m, what happens to this? An index being again with another index, what happens with this? The powers are being multiplied together. This is the same as a power n m. You multiply those ones up. So if you have number 4 law is, if I have a times b power n, what happens with this? Every number here say has the power up. So this is the same as a power n times b power n, provided b is not equal to 0. Because when b is equal to 0, the whole thing becomes meaningless. So those are the first items which we wanted to first look at as the first laws of these indices, as we are going to be following more and more. So we can first take even an examples. Example 1. Can say simplify the following. Simplify the following. Simplify the following. Part A. 2 power 4 times 2 power 3 times 3 power 1 times 9. So what I'm going to do is this. Look at this scenario. Look at this number here very well. We have got the least base is 2, and I have another base as 3. We have also got 9. But 9 can be broken into the simplest factors. So we can look at 9. Can we first break 9? By which factor can go in 9? 2 can't go there, but 3 can go there. By 3. Again by 3, 1. So where you see 9 is the same as 3 power 2. So what I'm going to do with this number now? We are going to say 2 power 4 times 2 power 3 times 3 power 1 times 9 is the same as, where you say 9, we are going to bring this term. So this is the same as 2 power 4 times 2 power 3 times 3 power 1 times 3 power 2. What I'm going to do now, when we are multiplying numbers of the same base, you can see these ones are having the same base. Even here, these ones are having also the same base. When we are multiplying, we recall on the first basic law of the indices. We add the powers. So we are going to say this is the same as 2. Then this plus this, 7 times. This is the same as 3 power. You can see this is 1 plus 2, you get 3 power 3. And this one becomes the other. This is how we do with all these numbers when it comes to the laws of indices. Follow them. Numbers of the same base, bring them together. Those ones with a differing base, also bring them together. Then apply the rules of indices. When we are multiplying, we add the powers. If there was division, we could just subtract those powers. So that was the first example as part A. So look at part B. So look at part B. So look at part B. We shall look at part B. So look at part B, which is giving us the best, such that you can easily do the needful. Part B, we have got 3 power 4 divided by 3 power 1 times 2 power 3 times 3 power 5. So what I'm going to do is that when the number comes in that manner, what do? So can you look at the least base? What is the least base? The number which is having this base is 2 power 3 and it's only 1. So can say this is 2 power 3 times. Then we come to the bases which are having the base of what? Of 3. We move to another one is 3 power 4. Can even bring another times 3 power 5. Then divide by 3 power 1. So we have tried to arrange it in that way. So this is 2 power 3 times. Then here we do the application of indices. We apply the laws of indices. So when we are multiplying numbers of the same base, automatically we add the what? The powers. So this is 3 power 9. Then divide by 3 power 1. Again, when we are dividing, what do? We only subtract the powers. So this is the same as 2 power 3 times 3 power, then we shall say 9 minus 1. So this is 2 power 3 times 3 power 8. So you have finished simplifying that one. That's how we normally go ahead with these numbers. And if you find that the number is bigger and you can easily break it to the smallest prime factors, do the needful before you add on more on that. Because if you don't do that, then the thing would not come out excited. So as we shall look at part C goes on 81 power 3 out of 4. We're also simplifying times 16 power quarter times 8. So we want to look at this one, again this times 27 power a third. So what we're going to do is this. When a number comes in this way, look at the bigger numbers. First break them. Like 81. 81, if you use the factor tree, this is the same as 3 power 4. What about 16? 16 is the same as 2 power 4. What about 8? 8 is the same as 2 power 3. What about 27? 27 is the same as 3 power 3. So when you see those bigger numbers, we are going to be substituting on these numbers. Then we apply our rules of indices. So we go on. Where there is 81, we are going to put 3 power 4. We say 3 power 4. Then the power is 3 out of 4. 3 out of 4. Times. Where there is 16, put 2 power 4. 2 power 4. Again times a quarter. Times. Where you see 8, we put 2 power 3. Times. Where you see 27, put 3 power 3 outside a third. Then we try to multiply from the other law of indices, that was number 3, that when a power is being raised and outside is also another power, they multiply each other. So what happens? This one is going to cross with that. We remain with 3 power 3, times. This one also reduces, we remain with 2 power 1, times 2 power 3, times 3 power 1. What do? Those ones with similar bases, bring them together, and those ones with no similar bases also bring them, put them aside. So what is going to happen? We're going to have 2 power 1 times 2 power 3, again times 3 power 3 times 3 power 1. So here you can see, when you're multiplying numbers of the same base, what do we do? The powers, we add the powers. So what we're going to do, this becomes 2 power 4 times again 3 power 4, and that one we have already tried to simplify our number. That's how we do those numbers. If they are in a bigger when they are complex, try to break them using the prime factor method, like what you used to do at the other levels in the senior 2, senior 3, senior 4. Even sometimes I had even in primary you are doing the same. In primary you also did the same. So when it comes here, we are just developing on the more and the more content on that. So if we try to look at another example to simplify on that, such that before we develop on other laws. Part D can come out and say 20 to this 3 power a half times 2 power 3 times 3 power 1 times 2 power a quarter. Now we are having in terms of other fractions. Still the same scenario applies. Those ones numbers of the same base, bring them together. What is going to happen is the same as 3 power half times 3 power 1, again times 2 power 3 times 2 power a quarter. What I'm going to do here, the base is the same. So what do? We are multiplying, add the powers. So this is the same as 3 power a half plus 1, again times 2 power 2 plus a quarter. So we can find there the LCM. This is a half plus 1, you can find the LCM. So the lowest common multiple there is a 2. 2 divided by 2, 1, times 1 you get 1. 2 divided by 1 you get 2. So when you add this one, becomes 3 power 3 out of 2 times 2 power. Now also there we get the LCM. So what is the LCM? The LCM automatically is a 4. So when you add, you are going to get 9 out of 4. That's how we normally do these, such a kind of the index numbers. Bring them together, break, collect like terms, then apply those rules. If you don't apply those rules, expect you may not achieve the best. That's what you can see, we are starting from the simplest up to the complex, but they are not always hard. And I advise people that this mathematics is very, very simple. What is important for you is practice. Always practice. And when you are done like this one, you are free to go on and practice more when it comes to backhouse, pure 1. Pure 1, can go to pure 1. It is chapter 9. You can open and practice more with it. Open, do more numbers. And when you get where you are stuck, you can email me on my email.